The reason why it's important to know how to rewrite a log into exponential function is because sometimes we can't evaluate the log by looking at it, and we need to rewrite it in exponential form because then that's how we can evaluate it. For example, if I gave you log base 2 of 8, and I could either ask you, okay, evaluate this, or I could even say equals x. So using the popcorn method, I'm going to rewrite this as an exponential, and I'm going to say 2 to the x equals 8. Alright, so you tell me, 2 to the what gives you 8? 3. Alright, next example. Log base 49 of 7 equals x. So we have 49 to the x equals 7. So how do we go from 49 to 7? Well, some of you might be thinking, okay, well, let's take the square root, but x needs to be an exponent. So from the rational exponent unit we just finished, x is going to equal 1/2. 49 to the 1/2, which is also the square root, is 7. Another example, log base 5 of 125. This time I'm not going to write equals x. So because we know how to rewrite, we're going to say, okay, well, that's still 5 to the what gives me 125. X equals 3. Next example, log base 4 to the 1. And I can ask you, okay, 4 to the what equals 1. Well, this is a special case because any number could be right here and we're going to still have x equal to be 0 because anything to the 0 power is always 1. Alright, now we have log base 2 of 1/2. So I can say, okay, 2 to the what gives me 1 over 2. Well, think about it this way. How am I going to get 2 on the denominator? I'm not going to change the value of 2. So what moves things in the denominator? That's a negative exponent. So we're going to have x equal to -1. Now if we kind of followed the same example and I said, okay, well, what's log base 2 of 1 over 4? You would say 2 to the what gives me 1 over 4. Well, how am I going to go from 2 to 4? I can say, well, that's if I square 2. 2 to the second is 4. But it needs to be on the denominator, so the answer is x equals -2. And my last example, log of 10,000. Now remember, there's no base in this log, so it's understood to be 10. So then you would say, okay, well, that's 10 to the what gives me 10,000. And knowing tens and our zeros, x equals 4. 10 to the 4th gives me 10,000. The last couple of examples we're going to do, we're going to evaluate all logs with a base of 10. So I could ask you, okay, what is 10 to the x equals 42? Well, I don't know what that is off looking at it in my head, so I know I'm going to write it as a log function and say log base 10, so I don't really need to write the base, of 42 equals x. Well, because my base is 10, it should trigger in your mind, okay, I can use my calculator. So I have my calculator out, and I press the log button, type in 42, hit enter, and my answer is going to be 1.62. We'll keep it to 2 decimal places. Next example. 10 to the x equals 0.3. As a log, that's going to be log of 0.3 equals x. So in my calculator, I'm going to do log of 0.3, and I get x equals -0.52. Last example, 10 to the x equals 7.6. Log base 10 of 7.6 equals, in my calculator, log of 7.6 equals 0.88.